Let's take a look at the basics of G-code. You don't need to necessarily know anything about G-code to slice and print files on a 3D printer, but in the same way that you don't need to know HTML to create and edit web pages, it can be helpful if you need to go behind the scenes to make some tweaks, or if you're troubleshooting why a print might not be working, or simply to just have a better understanding of what's going on under the hood, so to speak. So let's begin. I'll start by opening the 20mm box file. We'll use this as a simple file to examine our G-code. And I'm going to make a couple changes. I'm going to change the X and Y dimensions to 10 millimeters and uncheck uniform scaling so that I can change the Z dimension to 6 millimeters. And the reason I'm doing that is because I want this model to have 2 layers only for ease of viewing. And each of those 2 layers will be 0.3 millimeters in thickness. So we'll click Start Slicing, restore all the defaults, go to General, and you can see the first layer is already 0.3, so that's good. I'll change the second layer to 0.3 as well. Shells at 2 is fine. Infill, top and solid bottom layers doesn't matter because this model will, by default, only have 2 layers. I do want to make sure that the raft is turned off. And I do want the pre-extrusion line to print. So that's all fine. I'll click Slice and Slice Preview. And there's the model. We know that we can use the sliders to move from layer to layer. We can also use the arrows within the box. If you click in the box and use the arrows on your keyboard, I can go down to the first layer. And likewise, for that first layer, if I click in that box, I can use my arrow keys to move down, or the slider to slide all the way to the beginning of the print. On the right-hand side, you'll see the G-code that has been generated for this model. If your G-code is not showing up, and this is what you see, you can click G-code, or if this is what you see on your screen, then you can click this arrow and then click G-code to see the G-code. The first lines are all commented out, which means they are not being read by the printer. And you can tell that because the lines begin with a semicolon. So here you can see some summary information about our settings. Machine type is Finder 3. We're using PLA, 1.75 diameter filament. Layer height is 0.3, 2 shells, and so forth and so on. And now we get down to the start code. This is code that is executed before any print, regardless of what the model is. There are some slight variations in what these codes mean depending on which company's machine you're using. There is more or less a standard, and I will include links to reference resources online that you can go to look up any of these codes if you wish. But just understand that some of what you'll see here won't necessarily match exactly with what you find to be the so-called standards that exist. This first line, for instance, as near as I can tell, this sets a bounding box for an imaginary bounding box for the print that's going to occur. It's not clear why that is happening, and I've searched online and I haven't found a clear answer really for what that line is doing. The next line sets the bed temperature, so M40. If you have a heated bed, that's the code that you would use. It's setting the temperature to 60. And T0 refers to the particular bed in question. These printers only have a single bed, which starts numbering at 0. So bed 0 is set to 60 degrees. The next line, M104, refers to the nozzle temperature. And here you can see the nozzle temperature for nozzle number 1 is being set to 195 degrees Celsius. And the next line is also for a nozzle. That's for nozzle number 2, and it's setting that nozzle to 0. So of course the Finder 3 only has one nozzle, so that line is superfluous. But some of FlashForge's printers have 2 nozzles, and so in that case the nozzles may be set to different temperatures, especially if you're printing different types of material in each of the 2 nozzles. M107 turns the fan off, and we want to do that to allow the nozzle to heat up quickly. G90 engages absolute positioning. I'm not going to go into that in detail right now. G28 homes all of the axes, and so on. Again, I'm not going to go through all of these line by line. Just going to move down to the point where the pre-extrusion will happen. Remember, that's the wipe line that happens at the beginning. You can see that the nozzle will be 0.2 millimeters distant from the bed. And there's the appearance of the nozzle, and there's the pre-extrusion line being drawn. And the reason GCODE is called GCODE ultimately is because of these G1 codes. And these are directions for the tool head. So the machine is being told to move the nozzle to coordinates X and Y, X and Y, X and Y, and so forth. So it draws this box. Next is a raft. We don't have a raft, so we're going to skip to the next line, which is the first layer. And recall, we set the layers to be 0.3, so the nozzle will move up that distance from the bed. And we can see that more clearly if I go to the front view and also turn on orthographic view. So we're looking straight on at the print. Okay, and now if I advance, the first line is actually retracting the filament slightly, and then it lifts the nozzle, 0.3, and the F is the speed at which that happens. You can see there's a tiny gap there. And if I continue on, you'll see it positions the nozzle, and then it reloads the nozzle with filament, and we start printing the first shell of the model. There's the first shell, and here's the second shell, and now the nozzle moves to the interior and prints the first layer, the first bottom layer of the print. And you can see it's just a series of X and Y coordinates, one after the other. Now we're at the end of that first layer. The nozzle will move up 0.3 millimeters and then print the next layer. So for that, to see that, I'll come over to the layers, go up one, and then slide all the way down to the first line of that layer. And here you can see that's where we left off before. Click on the steps, and now I'm using the arrows on my keyboard to move down line by line. You see this retraction, and I know it's a retraction because of the E code here. If you notice, as we go through movement by movement of the nozzle, the E number increases very slightly each time. So this is the total, this is a a running total of the amount of filament that's being extruded. So in this latest move, we're changing from 27 millimeters to 26 millimeters. So we're actually retracting a tiny bit. And that happens when the nozzle jumps up a layer, and that's to help reduce stringing. So if we look at the front view again, and zoom in, and the next line, you can see the nozzle jumping up to 0.6. So it's not jumping up by 0.6, it's jumping up a total distance of 0.6 millimeters from the bed. So again, that's kind of our running total as well. And as we go through, the shell for the second layer is being printed. Notice that the inner shell is printed first, and then the outer shell. That's to try to assure a smoother finish on the outside. And then the solid part of the next layer is printed. When we're done, the M107 code turns the fan off. We have a slight retraction of the filament. The nozzle rises 0.1 millimeter and then moves to these X and Y coordinates over to the side. It's interesting to note that the last highest running total of filament was 39 or roughly 40 millimeters, which if you look at the estimate of material used is 0.04 meters. So those two are equal, right? That's just what we would expect. Finally, we get to the end G-code, and just like with the start G-code, the end G-code is the same regardless of your model. The start and end G-codes are inserted automatically by FlashPrint at the beginning and end of every model that you slice using FlashPrint. M104 is the nozzle temperature, and that's being set to 0. M140 is the bed temperature, that's being set to 0. G162 tells the Z axis to move to the home position at 1800 millimeters per minute. So the print bed will drop down to the home position. Next, the nozzle will be homed to the X and Y home positions. These next three codes do some magic with recording and setting the absolute and relative positioning of everything. And then finally, the last line, M18, disables the stepper motors. Now let's download this G-code file. I'll call it G-code to downloads. Save. I'll open a plain text editor, in this case text edit. I'll choose open, and there's the file that I just downloaded. And let's expand this and select all, format, font, show fonts, and I'll make that 24 so that we can see it more easily. What's all this gobbledygook? Well, I'm not entirely sure. It's something that FlashPrint adds to the G-code file when it exports it. But if you keep scrolling down, you'll see the date and time that this file was created. And then you'll see all the beginning comments that we saw earlier when we were looking at it in FlashPrint. Here you can see the beginning of the start code, and here's all the code that we saw. And if you keep scrolling down, you'll see all of the code that we saw in FlashPrint. Now, the main point of all of this really is to understand that the G-code file is simply a text file. It's just a plain text file. Very simple. We start with very complex virtual 3D models that are quite arcane, but we end up with quite a simple human-readable text file, which are simply a set of instructions, directions, literally X, Y, and Z directions, to tell the printer where to move the tool head and the print bed. Other than wanting to understand, to take a peek behind the curtains to see what's going on with the G-code file, there are a few practical reasons why you might want to occasionally come in here and poke around. Just one example. For instance, you can see in the end code, this is where the nozzle and the bed temperature are set back to 0. And if you're printing a number of small items, one after the other, you may have gotten frustrated with waiting for the print bed and the nozzle to come back up to temperature just, so you can print a 5-minute print. It might take longer for the cool down and the heating process to occur. So we can stop the cool down from happening. Of course, we could just delete that line, but in case you don't want to be that extreme, you can just add a semicolon in front of each of those lines. And so that essentially turns those instructions into comments that the printer will ignore. So the G-code will come down to this point. It will not cool down the nozzle or the print bed, but it will home all the axes and do all of the rest. The only thing you'll notice is that when you come back to your printer, after the print's done, that the nozzle and the print bed will still be hot. I'm not suggesting you do this. I'm just pointing out that you can override individual lines of code by changing the G-code. Of course, then I would save it out again and save the edited version to my thumb drive and plug it in. So that's a relatively quick overview of G-code. If you're interested in more detailed dive into G-code, there are many online resources that you can consult. For instance, the RepRap wiki, which goes through all of the various codes. I'll also link to this PDF file that I found on a Reddit discussion thread, and it shows some of the variations that FlashForge uses, sort of some of the non-standard things they do, but not all of them. So just always keep in the back of your mind that there may be some variation between what you're seeing in the code and what the accepted standard use for that line of code is. But that's a small caveat. Most of the codes line up with standard code.